The new project that we'll present today has a goal to develop corn plants with enhanced resistance to stalk rot. So why are we focused on stalk rot? Well, this graph shows the major typical diseases that corn growers in the U.S. face in terms of impact on yield loss. Two diseases that are difficult to control and have very severe impact are the stalk rots and the ear kernel rots, shown by these green bars, these very tall green bars on the right side of the graph, with an estimated yield loss of about $1 billion annually due to stalk rots alone in the U.S. There's a clear need for some good new solutions to this disease. Traditional breeding has yet to deliver good resistance to these pathogens, so this makes it a really excellent target for a biotech approach. And in addition, because some of the same pathogens cause both stalk rots and ear rots, there's the potential for us to find a single solution that addresses both diseases. These two pictures on the bottom show how stalk rot affects the health and productivity of the corn plant. In this picture on the left, you can see a corn stalk that's split in half, showing stalk rot damage in the center. By these dark lesions. This type of damage causes poor grain filling, resulting in yield loss. And when it's very severe, you can actually get lodging like this. And you can imagine that this type of scenario is really catastrophic to the grower. So we'd like to now pass around a few corn stalks that we've infected with the stalk rot pathogen, just so you can get a clearer view of the disease. This infection method and then splitting and measuring the lesion size is one way that we're able to assess resistance and susceptibility in the different varieties. So clearly, there's a need for growers to have some better and new solutions for stalk rots. And compounding the problem is the fact that current agronomic practices actually present a kind of double-edged sword. The higher planting density, growing corn continuously, and reduced tillage all allow for higher yields and therefore increased income potential for the grower. But at the same time, these same practices increase the risk of stalk rot. And that's due to fungus buildup in the soil, stress on the plants, and creating an environment that's conducive to disease spread. So by offering a biotech solution to the stalk rots, we help preserve that high rate of return for the corn grower with this increased income potential by mitigating that stalk rot risk. And this manifests in better harvest efficiency because you mitigate this risk of the lodging, lower drying costs because the grower doesn't feel the pressure to go into the field and harvest early before the corn is dry, and increased hybrid selection because as a biotech trait, it would be available in a variety of germplasm.